For any assignment-related queries, call us at +1 678 648 4277. You can mail us at support@statisticshomeworksolver.com or reach us at https://www.statisticshomeworksolver.com. Interpreting data analysis results using ANOVA. Here, we use ANOVA to analyze mean scores for Quiz 3. We will then use variables to carry out a data analysis plan. We will then interpret all the results and give a conclusion. Task Data Analysis and Application, DAA, Template Data Analysis Plan 1. Name the variables and the scales of measurement. 2. State your research question, null and alternate hypothesis. Testing assumptions. 1. Paste the SPSS output for the given assumption. 2. Summarize whether or not the assumption is met. statisticshomeworksolver.com. Results and AMP, Interpretation. 1. Paste the SPSS output for main inferential statistics as discussed in the instructions. 2. Interpret statistical results as discussed in the instructions. Statistical conclusions. 1. Provide a brief summary of your analysis and the conclusions drawn. 2. Analyze the limitations of the statistical test. 3. Provide any possible alternate explanations for the findings and potential areas for future exploration. Application 1. Think of your own field of study. Describe how this type of analysis might be used in your field. 2. Analyze what the value and potential implication of such an analysis would be. statisticshomeworksolver.com. Solution. ANOVA. One way ANOVA was used to analyze whether the mean Quiz 3 scores among sections were same or different. A test for normality of dependent variable was also performed to test for normality assumption. Data Analysis Plan. The variables used in this analysis are Quiz 3, number of correct answers in Quiz 3, section of the student. Quiz 3 is scale variable, and although they are discrete, they are quantitative in nature, and we will treat the variable as continuous scale variable. Section is nominal variable with 3 categories. The research questions in this work are: A. Is there significant difference between mean score in Quiz 3 among students of different sections? Null hypothesis is that there is no difference between pair males and females in terms of previous grade. The hypothesis can be specified mathematically as statisticshomeworksolver.com. Hypothesis 1, and represents the population means of previous Quiz 3 for the 3 sections respectively. The alternative hypothesis is that at least a pair of means differ. Testing assumptions. The descriptive statistics obtained from SPSS is below. Table 1, Descriptive Statistics. Descriptives Quiz 3N Mean STD. Deviation STD. Error 133.151278.222.239.6.771.4950333.7.941.560 0.272 total 1057.26 statisticshomeworksolver.com. The above table summarizes the mean and standard deviation of the Quiz 3 score in 3 sections. The average score of Section 1 was M equals 7.15, SD equals 1.278, Section 2 was M equals 6.77, SD equals 1.495, and for Section 3 M equals 7.94, SD equals 1.560. The means do not appear close to each other, although the standard deviation seems close. Tests of normality. Kolmogorov-Smirnova-Shapiro-Wilk Statisti, CDF Sig. Statisti CDF Sig. Quiz 3 0.148 105 0.000 0.946 105 0.000. Table 2, Test of Normality Table. Lillieffer significance correction. The normality assumption for variables was not met for Quiz 3 as the Shapiro-Wilk test gives statistically significant result. This was expected as the Quiz 3 variable is discrete in nature and only takes integral value. Results and interpretation. The one-way ANOVA results obtained from SPSS table is given below. StatisticsHomeworkSolver.com. Table 3, Independent Samples t-test table. ANOVA Quiz 3 Sum of squares df means square f sig. Between groups 25.013 to 12.5065.9320.004. Within groups 215.044 102.108. Total 240.057 104. The ANOVA table clearly outlines that there is insignificant evidence for a significant difference between the Quiz 3 score between different sections, F equals 5.932, P equals 0.004. Hence, null hypothesis of no difference was rejected. It was concluded that mean score of 3 sections were not same. Since null hypothesis was rejected, a post hoc comparison was run to check which pair of differences were significant. Table 4, Tukey's HSD Multiple Comparison Table. StatisticsHomeworkSolver.com. Multiple Comparisons Dependent Variable, Quiz 3 Tukey HSD. I, Section, J, Section. Mean difference, IJ, STD, error sig. 95% confidence interval lower bound upper bound 120.3820.3430.508 minus 0.431.20 3 minus 0.7880.3570.075 minus 1.640.06 21 minus 0.3820.3430.508 minus 1.20 0.433-1.170 asterisk 0.3430.003 minus 1.99 minus 0.3531 0.788 0.3570.075 minus 0.061.64 1.170 asterisk 0.3430.0030.35 star. The mean difference is significant at the 0.05 level. The multiple comparison table shows that the pair which had significant differences in mean was section 2 and 3 with 95% confidence interval for the difference being 1.99. 0.35. Hence, it was concluded that average Quiz 3 score of Section 2 and 3 were significantly different but not that of Section 1 and 2, and that of Section 1 and 3. Statistical conclusions. StatisticsHomeworkSolver.com. The results that were obtained in previous part show that there is significant evidence for the difference between Quiz 3 scores among 3 sections. The main assumptions of ANOVA were not satisfied, making the result a bit unreliable. It is concluded that the average of Section 2 was different from Section 3, but other pairs were not significantly different. Application. ANOVA is extremely useful and powerful tool to determine the differences between the more than 2 classes. It is of prime importance in many fields and used to strengthen the empirical evidence. In finance, it can be used to test if different sectors have different annualized returns. In medical sciences, it can be used to test the effectiveness of more than 2 treatment using a randomized experimental design. It has very sound theoretical support, and application of ANOVA can be seen across disciplines. StatisticsHomeworkSolver.com.